Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat. But before we begin, I'd like to quickly review two items, our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. The session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our on-demand content. And if you have not been on a live stream to YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. I'm going to bring in our speaker here for today. Hello, hello.
Hello, everyone.
How's it going? Welcome back to the Reactor.
Yeah, thank you, Alexia.
Yeah, we're excited to kick off this session. So without further ado, take it away.
Yeah, thank you. So welcome, everyone. So we're going to talk about today demystifying agent development. So we're going to know the basics here on developing an agent, what's an agent, and to deep dive a bit on it on how to develop and deploy your own AI agent. Short story about myself. So my name is Jan. I'm a software and AI architect with more than 10 years of experience. Currently working as a technical lead in a Swiss company named Givaudan, specialized in fragrance and flavor. And I've been doing conferences, sharing code and posts. So keep free to follow me on my socials. And this session will be published. These slides will be published on my blog too. Let's start. So as we can see, we are talking a lot about agentic AI, a lot of stuff about it. This is just a few of them. We're not gonna deep dive for all of these topics, but we're gonna talk about the LLMs and the agents and new ways is coming out. So it's really important to try to understand the basics here before starting to try the other ones. So at the beginning, I wanted to define what's a generative AI. So it's a branch of artificial intelligence, but it's focused on creating new content. So basically, traditional AI will classify, predict based on data. Compared to generative AI, we can produce original output such as images, text, music, and a lot of other data, and will be generate this type of things based on the data the model are trained on. And let's talk about large language models. They are an advanced AI system that understand and generates natural language like human-like text, and they are trained on machine learning techniques. And the large language model, it's part of the generative AI part. Start with how to chat and to use an LLM today. So the basic one, you normally already work on it and already use. It's the you are a user, you are just sending a message, a user prompt to your chat, and your large language model will handle this part, and you will get the answer from your large language model. This is the first step, the basic one, when you are doing a chat. But it will be only limited to the knowledge of the large language model and what you will give it in your prompt. And talking about prompt, you have to be a bit careful about what you are asking and how to ask it to the large language model to have relevant output. So this is an example I found, which is really, really good, giving some tips on how to prompt correctly, like giving context, giving what you want it to do, the audience, and so your large language model will be able to answer you in a proper way and not just trying to guess something or to hallucinate. Next step, it's we have a chat, but we wanted to go further and to have the chat completion. What's the chat completion? In OpenAI, for example, instead of just sending a message and having a message out, in this chat completion, we can send a conversation in. So a list of messages and continue to have a single output as a text messages. And the chat completion, your text, the prompt you are sending, it's based on tokens. This is something important to understand for the next steps. It's not only character or word, but it's token based, and your models will be limited on token in input and output. So in this token windows context, you can, at the beginning, you were limited to 4K in input and output, so it's like it was great, but you've been not able to put some long documents and complex input or output generated. But with the new released model this last month and years, we have context in inputs more than currently millions of tokens, and in the output we can reach out now with hundreds of thousands of tokens in the generated output. So you can add a lot of code, for example, in the context or documents in input, and so you can generate a lot of content in the output. Just a quick example on under the hood, a bit technical, but to show how is it working, technically speaking. So we are sending a post request on an endpoint, and we are sending a JSON data. This is the starting point for to do a conversational assistant or just sending chat completion messages. So the important topics we need to care here, it's the model you are using at the beginning, so you can specify if it's 4.0, 4.0 mini, the new one release, so there is a standard way to call all of these ones. And the messages part, it's the heart of the conversation here, and you will have different roles here. The system prompt, it's you are sending this one if you wanted to specify how your LLM will answer you and give it guidelines, and it's something you will not send every time. So it's something you will define one, and you will maybe never see this one if you are just using it like ChatGPT or something like this. You will be able just to use your role user, which is the message sent by the user. And here is just an example with the content. The temperature here, the parameter, it's to address the creativity of the model. The stream, it's just to have something streamed or blocked and to have the whole answer in once. And the max token, it's to be able to manage the output of token generated by your model. You don't want every time to generate a long text, or if you have a dedicated endpoint to generate some short things, you can set up this one to have this more manageable. The answer we are getting from the models, it's this one. We are just gonna take and check the message section, which is the most important for us here. And what we are noticing is we have a new role, which is assistant. So all answer from an LLM will be with assistant role. And in this example, if we start and continue our conversation with our models, so what we will have is all of these messages can be put just after these messages. So you can have a list of messages who will increase with your conversation. So you will have your user assistant messages increased in this message section. Now we can chat with our model, but we want to integrate some knowledge based on documents. So how to do this part and how to display this one. So the same workflow, we are starting with the user prompt, but in a certain point, we will retrieve some documents and knowledge before calling our large language model. And at the end, the workflow will be the same to answer to the user with the prompt and the knowledge base on the right. Our agents, our chat, it's becoming more intelligent and getting more knowledge, but it's limited with the data source of the user. But if we deep dive a bit on how RAG is working, so the first step is to be able to chat with these documents. We need to do a document ingestion. It's a process to do a data transformation to let your large language model to be able to use some of this data. We will transform the user query into a vector because it's not something we can use and query our knowledge. At the end, we will be able to do this search in database, and finally, we'll add this context to our final prompt and to be able to answer to the user. So let's start with the document ingestion. So we are starting with all of our source material, can be PDF, Office, depending on the solution you are working on it. And you will have to convert this. This is a simple way to do it. So to convert it into chunks. So it's like you can have few mechanisms of the chunk, but the basic one is you have 10 page for a PDF. So you will have a chunk per page. So we'll just extract the text from each pages and put it in a chunk. And for each of this chunk, we have to calculate the embeddings representation, the vector representation for this. And we will call the embedding model from ChatGPT. We have other model we can call too. And we'll just call here to have this data back. And we will have for each of our chunk an embeddings representation. What we will do at the end, we will store all of this information in database. So we'll have the chunk and vector representation for each of them. And we'll save all of this information. We can save more information like metadata, the name of the document, the page, in the same way. And the next step is, okay, now we have our data processed, and we want now to query this data. So what we will do is we have to transform the user query into a vector tool to be able to do this comparison with the data we have in database. So the first step is take the user query, do the same thing we did with the RAG, get the vector representation, and with this ones, we'll be able to do the search in the database. We have some library doing all of this job in an easy way. And we'll be able to get the top end results representing this data. And at the end, we will add this new detected chunks and documents into our new prompt. So we'll augment our prompts before sending it to ChatGPT, for example. So we'll have our initial prompt. We'll integrate some other prompt. We will integrate to say, okay, this is the user prompt. This is the document or chunks we are integrating. We can have, we can give some more details on that. And at the end, we'll be able to call the LLM with this and to get our answer. Now we have our workflow working well. We want to go a bit further and to try to develop our AI agent and to have autonomous work. So what's an AI agent? It's a semi-autonomous software that leverage large language model to operate independently and accomplish complex tasks. So the most important part is the way to do some action autonomously and to be able to route, to do some predefined task or workflow. We can work on it, and all of this variation are considered agentic systems. So we'll deep dive in which on each of them and how is it working and how to develop agentic systems if you want to have an AI agent working on different situations. First one, the building block. It's the easiest one. It's just you have your large language model and you want to give new tools, memory, or doing RAG. So you will just enhance your large language model with augmentation we just showed before. And put some of these tools. And for example, the example we can give it here with the tools is the weather API. So basically, when you are chatting, you can't get this type of information, but giving a tool to your large language model to be able to query the weather API and to get this, it's the first step. Chain workflow. It's another simple one. This is the principle of breaking complex tasks into simpler one into manageable steps. So we can have, for example, marketing copy we wanted to generate, and after that translating it. But if we wanted to iterate in the marketing copy, we mainly don't want to do a single big prompt doing all of the job, but we can split this into tasks and work on each part separately. And even for the translation part, you'll be able to call another one for grammar or calling an external tool to do this one if you want. The parallelization workflow, it's to be able to run tasks simultaneously, and at the end you can aggregate the final result. In which context this one can be useful? It's, for example, you have some code and you want to run parallel tasks on it to check the security, the performance, and the quality. So you will have dedicated LLM agent will be performing each task differently and be dedicated for this one. So with knowledge, with different prompt and dedicated to this task. And at the end, you'll be able to aggregate the final result of this one. Another example can be, I want to generate a complicated blog post, for example, and you want to do a web search. You want to call, for example, all your documents already available in a RAG. And so you can do all of these requests in a parallel way and to just aggregate the final result to get your output. The second one, it's used a lot. It's the routing workflow. The job on this one is to detect the intention of the user and to distribute the task. So, for example, you want to call and to generate an images in ChatGPT. The models himself don't know how to do it. If there is a dedicated model with DALL-E, with GPT image one, for example, or even if you want to implement another one with Flux AI or Stable Diffusion, so you can have this LLM router will detect the intention of the user and will route directly to the dedicated agent you wanted to implement, for example, with some complicated task for generating with all three models, or to be able to generate images with another one. And to have, for example, reasoning models dedicated, so you can lower your cost of the LLMs depending on what the user is asking, and not always call the same large language model. And the orchestrator workflow, this one, it's a combination on the previous one. So we'll be able to call a few LLM and to synthesize at the end. delegate the task for this. So it's an aggregation for all the previous one we already saw. And for example, for this one, we can search with the database and the web, learn large language model, and at the end get all of this data. And we'll be able just to orchestrate and to call a few of them and not all of them at the same time, depending on what we asked previously. And this one, it's about the evaluator optimizer. It's like what we are developing in the reasoning models. You have your question, and sometimes you are not happy on what you ask, or maybe you don't prompt correctly, or you have to prompt a few times to have your result. In this one, you can create an evaluator to be able to get your result evaluated and having a loop to be able to improve himself. So if the evaluation it's not validated, and so you will iterate through your evaluation process, and if it's validated, so you can go out and give the result. You can have a max step to manage the out if to not stay in a infinite loop. And for example, we can integrate this with a translation assistant. For example, you are translating a lot of documents. You create an agent dedicated to this one. To be able to evaluate each time what you are doing it's correct. So you can improve this with this evaluation. And now let's summarize this one with the previous diagram we just show and where to put this agent. So we still start with the same thing, but instead of directly calling all of these things, we can integrate all of these logics into something we'll call agents. And this one will operate and call the knowledge, the tools, and at the end, with this knowledge, an action will be able to answer directly. So we can summarize with this type of things to say the agent is now the heart of our chat. And now our agent is becoming more and more intelligent, and now few sources, few documents and tools, and becoming more complex. But if we want to go further and to have dedicated agents, so here we will have multi-agents. So with this one, we can separate tasks into different tasks to be able to handle a lot of different use cases with the same input. And now we have a complete workflow with complex chat work. Now we introduce the agents calls. So we will have few agents, how this agent will communicate between them, and if there is something to call the tools or knowledge externally. So is there a protocol to do this one? Yes. Few months ago, Anthropic open source this model context protocol. We heard a lot about this, even this week with the Microsoft build that there is native MCP support with Windows. But what is MCP? It's like the USB-C for agents. So it's connecting agent to tools. It's like instead of calling and developing all of these API calls to technical things, you will have this MCP protocol will give all of this context. Someone have to develop this MCP to API, but at the end, when it's developed, all of your agent can just communicate with MCP protocol, which is more readable and easy to implement. And it's a standard way to be able to communicate from your agent to external tools. And the second one introduced by Google is to agent protocol. This is the simplification of communicating between agents and not directly to tools. And if we illustrate this one with our diagram, we can just split our agent and put the agent-to-agent protocol between them. And with all of our external calls with tools or knowledge, we can use the MCP protocol. It's not mandatory, but it's something we are integrating more and more. But you can have function tools, function calls instead of MCP, or just doing your own API calls or services here. Let's talk about the AI agent services in Azure. So it's now generally available. And how is it working? So the first step we need to understand when you are developing agents with Azure, it's like the OpenAI assistant, if you already heard about this. When you start, you have your agent, you create your agent. I will just show later in the demonstration. And when you have your agent, to start a conversation, it's not like the I display with the chat completion. You have to create a thread of conversation. You create a thread, you put messages, and you have to run your agent. And when you run your agent, it's something did in parallel, asynchronously, and you have to check the run status on it to display at the end, when the run is done, the final result. Like here we can have an example, complete example of an agent running with, for example, the Microsoft Sales agent. You give an instruction. What you have to decide is to which model you want it to use. So you have a lot of models, even the newly released the Grok model. You'll be able, and you will connect some tools, some knowledge base with Azure AI Search, or file-based with the embedded vector store in AI agents, or you can connect few tools with the code interpreter, for example, the Bing search to do some web search. And at the end, this is the result we can have when you will run a thread in your agent. So you're starting with your message, tell me the total sales by region. And in this one, your run will be able to detect the function you want them to use, and it's called to the database. So the agent will give you the call to do, and you'll be able to execute this request. And at the end, you'll be able to display your messages into your thread of conversation. And with the code interpreter, you can go further and to integrate code execution. And for example, based on the previous data you generated, you can create some pie chart, for example, and using Python libraries. If we want now to not use directly agent, or want to use the AI agents on Azure, you have a lot of SDK currently to let you develop your own AI agent or conversational assistant. This is a list of them. There is also one, for example, with the AI agent development, like Pre-AI, or other one, but with LangChain, with Spring, for example, if you are a Java developer, or even there is a lot of SDK or given by Microsoft. You can use all of them to do your developments. And now let's start our demo. So I will start by just showing the code here. So I will just run the application. It's running. We'll just lower this one. So what we have here, it's a Next.js application. And it's a really simple one. I prefer to use this one for the demo because it's really too simple to implement it. So we just have a page which will just handle the view of our application, nothing much on this part. And the important part I wanted to show, it's the API, the root part, and how our agent will work. So here we are just defining the connection to our database, to our AI Azure account with OpenAI. And at the end, everything will happen at this section. We'll handle the API. So the first step of our agent, it's the classification prompt. Here we are implementing a routing workflow, and we are implementing by ourselves. So in the first step, what I want to do is to detect what the user want to do. So I developed three different agents: a general purpose agent, a refund agent, and a technical stuff agent to handle my computer issues. And a second thing I want to detect is the complexity of the request, if it's something simple or complex, and to not to be able to switch between LLM models to have complex requests, send it to, for example, a O3 model having a reasoning capacity. And the first step for this, so when I have this prompt, I will call ChatGPT with a structured output here. I'm just defining the result I want to retry. I'm just calling a quick GPT-4o mini request, which is really good for a quick task. And I will get my my result at the end of this result. Based on all of this result, I will create a new prompt and route to what I want. So the general one, the refund, or the technical one. So I have my free agent here, and I will just detect which I wanted to use here and detect my agents. So I'm just getting my classification and detecting which one I'm using, and creating my final prompt here to my application. And at the end, when I will send this one, I will just switch between models if I'm using a simple or complex task. It's a bit technical, but I will just jump now to the demonstration and illustrate this one. Let me just open this. Here are application. So it's just a simple chat UI. So here, if I start my conversation with a hello messages, so we are detecting the routing, and this one is a general helper bot. There is nothing specific to talk about this. And for example, if I said I need a refund of my last order, and here what we can see is we are switching between agents and at this stage, I'm just displaying which type of task he's performing, which is just a simple task and nothing complex on this part. I can switch for the technical part, saying I have an issue with my laptop. And in this one, I will be redirected to the tech support wizard, which is the third assistant will help us to perform this type of task. And how to handle the complex queries. For example, if I ask, can you generate a complex, not full in yes, blog posts about, let's say, cloud computing. And now we will have our answer. But if we just check who answered this, it was the general helper bot. But instead of just using the simple task, it will perform this with the complex one and with the reasoning models for performing the request. So this is just a simple way to develop agents and to do this type of routings. And now if we switch to this demonstration I wanted to show, this is the UI for Azure AI Foundry. This is the portal you will find and develop your AI services, AI agent, and deploy your model. So what I already did before is I deployed different models on my on my AI Foundry, and I created agents. So what I created. So you can now create agent directly here, and to handle this part from Azure, and you can handle the multi-agent talk. So what I did here, I created a blog post generator agent, which is just a basic agent generating blog posts, and I just give instruction about how to structure it to answer only in Markdown, for example, which is really important when you want to publish something quickly. Another one with a translator agent, just a simple one translating the request of the user, and here you can give some tips and how you want it to have your translation, so you can have dedicated agents. The other part, which is really good, it's you can select your models, which one you wanted to use in which case. In this one, I can just have the 4.0 model, which is good. And for example, for the coding agent, I want something quick and working well. I can switch for the 4.0 mini, or even the newly released the 4.1, which is really great too, or the other models. I can switch here from my models. And this one is the same thing, just a coding agent with some base generating some code blocks and just having Markdown as an output. I can talk directly with each of them, but the interesting part is try to have a routing mechanism in Azure, and to have a single agent and to switch between all of these agents. So what I did here is I created a demo agents with a base model for the usage. And I said this is a coordinator agent. And I give some knowledge, actions, and agents. What I give from knowledge is I give the Bing search base. So it will be able to call web to perform some calls. I give a search index here. This is just a few documents on Givaudan sustainability informations. Another one, it's an API call. This one, it's an example to just get the current time, because the LLM not be able to do this, but you can integrate your open API tools here, and to be able to call, you have to define if it's authenticated or not, but you can call and give the knowledge to the LLM to call and to do actions. And the last part is I connected this agent to other agents. So he is able to handle the blog post generator, the coding agent, and the translator one. You can activate the voice if you want, but what I will show finally, it's the instruction I put here to say him it's a coordinator agent, and will handle the part to call the other agent if needed. So, and the other part I want, it's my agent. I want to be able to call Azure AI search to get some information, for example, if it's non-code, blog post, etc. So if I want to have an agent more dedicated on the knowledge I already have, for example. Let's try this one. Try in playground. So you will switch directly to the playground view. As we just talked before, you will have a thread section. So each time you're starting a conversation, you will have a thread of conversation. And if, for example, we are just saying who is the latest US president, for example, this type of LLM will not have this information in his training. So what he will do here, he will call Bing search to get information from the web. So to be able to answer correctly. Let's try another one, and let's say, for example, do you have any information about Givaudan sustainability? In this one, depending on what he has as information, he will switch. In this one, it just take the information from web. We'll try another one later by starting directly the conversation with the other one and switch on the Azure AI search view. Let's start a new one directly. I think create a new thread. Now this one I don't want. You don't want to switch directly for the Azure AI search. I think it's more about on the prompting. I will just try it at the end to do the switch to force him to just quickly call my Azure search, which is really important here. It's to put a lot of context on your messages, to say why and how to call this type of knowledge and external sources to be able to answer you. Let's continue the workflow and, for example, ask him is the current time at Toronto. And now he's switching automatically to the OpenAPI endpoint, so he will execute the this action and get the answer. I don't know if it's because they roll out all of these things this week with the new generally available agents. It's a bit slow, so let's not wait for. Oh yeah, that's okay. It can maybe depend on the API I'm using here. I'm using an external public API, so it can maybe take time to have this answer. So currently I get my time, and let's do some other tools calls like generating code. And for this one, the first step is detecting the agent used here and to call the agent for this one. Okay, we have our code generated, but the important part we want to follow here is the thread information and to see what happened under the hood. So for example, for the last messages I sent, we can see that I sent this message and it was the coding agent detected and with the outputs. You can see the same thing with the previous call with the OpenAPI call with the date time. You can see the arguments and all of this input and output, which is really, really great to debug. And the same thing for the grounding here. When you don't have the information, you can see the request send and how he's handling this part of the conversation, and even the message created, which is really, really good. I will just change this one, and I will just remove this section. Saving, creating a new thread, and we'll try again. And now it was about the prompt I updated, but at this stage, what you can see, we'll show it in the beginning. It's still under generating. It's generated now. So I started to ask my question, and he detected he asked to call the Azure AI search, and which is really good here. You can see the output and all of the documents used to generate this one. And in this one, we have our result coming from the knowledge based on our RAG. So you can get all of your information. You can get the documents here based on it. There is an issue to get the document from the UI here. It's not correctly linked. But if when you develop this one and you use the SDK to interact with your agent, so you can have all of this information from here. As you can see, you will have the IDs for each document on your AI search, so you can just get them from there. So this is it for the demonstration. Let's back to our presentation. Let's just which is the slideshow. If you want to develop your own and want to have some resources for all of this, so this is a few of them to start. I even published the code I displayed just before the Next.js starter, so my GitHub, and you can find all of the other links here. There is a lot of documentation. There is a lot of simples on Azure, so you can just go here and check the documentation, and here just the base documentation of the agent to agent and the MCP protocol. That's all for me. Thank you for your attention, and I will check if you have any questions. Let me check if I think I don't see any question. I think Alexia. Yeah, I think it was clear.
Yeah, I think everything was pretty clear. No questions in the chat, although we could give another minute or so for those who may have something coming up. But thank you again so much for today's session. This was super great. And thanks everyone who joined. Once again, we're here for another minute to answer any questions you may have. But if there is none, then I think we can close up for today.
Yeah, and if some question happening, don't hesitate to connect with us. We'll be happy to answer later.
Fantastic. Thanks again so much for today's session, and we'll see you on the next one.
Yeah, see you, Alexia. See you, everyone. Bye-bye.
Bye, everyone.